and then do a quick recap of what you said.
Just started. Let's go.
Okay.
Okay, for those of you who didn't get it, welcome. Today we're doing physical pen testing. Welcome back. Okay, so quick mention. We're talking about physical techniques here. So I don't want to see any of you guys practicing on UF infrastructure. We're talking about non-destructive stuff, but even still, it's non-destructive with an asterisk. So there are many ways to break into a building too, and you guys are on the hook for the bill if you break shit. So please don't. That being said, like the stuff that we're not really gonna talk about is drilling locks, breaking windows, smashing computers, or like cutting wires or stuff like that. That's all stuff that's kind of outside of the scope of this today. And while it is extremely important to consider these when you're like talking about security concepts, it's maybe not the most forward thing to think about for pen testing. But definitely think about it if you guys are interested in securing your physical stuff. Yeah, don't do it at UF. And if you do, you didn't learn it from me and not UF sit. So, wait, what? Okay. We're gonna start off with the lock. So in about, I want to say 10 minutes, we're gonna have a bunch of locks for you guys. My friend is coming to bring a bunch of locks and lock picks, so you guys are gonna be able to try these out yourself. So we're just gonna go over quick basics, and then when that comes, we'll be able to do that here. So this is just how a key normally opens a lock. You have key pins and you have your tumbler. So you have key and driver pins. Your key pins are the ones that interface with your key. And once they push the driver pin over that line there, it's called the shear line. Once all of them are over, the key is able to freely turn because there's nothing in the way of the core from rotating. Right.
Can you explain what a tumbler is?
So this is a pin tumbler lock. So you see all the pins kind of like going down into each of their chambers. This is just the kind of the style that the tumbler lock is. Right, and the way that physical pen testers modify or attack these locks is usually with lock picks, although it's not super common if you're actually like trying to break in to test the security of some place. While you see it a lot in media and it's portrayed a lot online, it's kind of slow. It's harder, especially nowadays with a lot of bitted pins, which make it difficult to actually lockpick, but it's still a pretty valuable skill. So the way you do it is by turning the tension rod and by moving your pick up and down over the pins. So why do I say that maybe not everybody uses this skill nowadays? It seems like locks are pretty ubiquitous. They're pretty everywhere. Like you should probably know how to at least use like some locks. Well, there's definitely alternative methods. So there's bumping, which is like taking a key and hitting it with a hammer, basically. And just shooting those pins up. You can also just bypass the entire latch mechanism using a shim, which will push the latch out of the way of the lock. And instead of individually pin picking, you can just comb it. So you just move a pick back and forth really fast. It'll push all of the pins up, and then hopefully they'll land above the shear line and nothing else will get caught. And then it'll open the lock. And if you have an especially vulnerable lock, I would say, there's an attack for comb picking, where you raise each of the pins above the shear line. So both the key and the driver pin are over the shear line, and then you're able to rotate the lock. I'm going kind of fast. Does anybody have any questions? Yes. Shimming, yeah. So you have your lock, and that's a padlock there. So you have your shackle. Once your shackle, if you've ever opened a padlock before, you'll notice it has like a notch in it, right? So whenever you push the notch closed, there's like a bearing that goes and interfaces with the lock. You can basically like move the latch away from the lock by using a shim. Yeah, so you align it with the shackle and you push it down, and that'll open the lock. I actually have some shims here. I don't know if we have any padlocks coming, but this is going to be like a really I'm trying to speed through these slides. We have like about 50 slides. So we're gonna go really, really fast and just kind of show you guys all the different techniques. And if you guys are interested in something, hopefully we'll have it up here and you can try it out. That being said, if not, then we'll definitely like to talk about it. So any questions you guys have, I'd love to talk about.
I have a question about bumping.
Yes.
So the key you use is not the key for the lock.
The key you use is not the key for the lock.
Does it destroy the lock by bumping it?
So it is not non-destructive. So almost any attack is not going to be completely non-destructive. You have the chance of you have the chance of breaking off your part of key or bumping key in the lock, or damaging the faceplate or the internals of the lock. But usually a bump key, as you can see here, always has like it looks kind of wavy, but it's really low down in the key profile. And it's usually the same bitting repeated over and over and over again with kind of like a wave. Any other questions before I move on? We're going to be able to try this in just a second, so I'm sorry if we're moving kind of fast. And we do have a physical door over here. We don't have a lock on this door, but you will have locks around. So if we're going to go over door attacks in just a second, if anybody wants to try like a attack, we might have something up here you can try that on. Awesome. There's also keypads and digital locks. So you guys are probably familiar with a lot of like attacks for keypads and digital locks. You can do sniffing, cloning, or like replaying attacks. You can look at the repeat like the wear and tear on different keypads. And also, I think this one on the top left is actually using UV powder and like detecting the traces of fingerprints on locks or on keypads. I apologize. And I just wanted to throw this in here. We have there's also possible to do safe cracking completely autonomously with just this like robot here. Just spins the dials really fast and opens the lock in like a matter of seconds. Okay, now we're going to talk about how you can attack the key. So there's key impressioning, duplicating, copying, and decoding, and there's a bunch of other stuff. You can impression a key, definitely using like putty or like a mold like surface, and just kind of pushing your key into the mold. It'll leave like an after image when you pull it out. I actually have some of that up here today, I believe, if you're interested in that. And then once you have a 3D mold, you can actually make a casted key with like a kind of metal like this. I wouldn't suggest maybe touching this one because it has lead in it, but you can. It's a low melting point metal. You just heat it over a fire for a couple seconds. You pour it into the mold, and out pops a key. It's not super like resilient. You have to be very careful with molded keys, but it's still, I think, quite fascinating. But what if you don't really have access to the key for like a certain amount of time, or you don't want to like impression it? Let's say that you're just like a physical pen tester. You've made it into the entryway of a building, and your task is to escalate. You have to escalate your position. Well, it might be interesting to find like useful keys, valuable keys that are left out. And let's say a security guard left their keys on the counter. It happens. You can, if you just take a quick photo and like pull it up in Photoshop, there's these things, these files online that Deviant Alum posted for, is it key measurements? Yeah, here. So these are the different key bitting values and measurements. So if you know the kind of brand it is, and you know the like the key you're dealing with, and you have a photo of it, you can actually decode the key and recreate it just from a photo. So that's also something to keep in mind. Does anybody have any questions so far? I'm kind of
yeah.
yes, of course.
For that key decoding from an image.
Yes.
Are there automated tools that?
I don't know of any. I'm sure there might be, but I don't know of any. Especially because a lot of the, I would say that you're not going to get photos that are going to look super great. You're going to always have to kind of touch them up in Photoshop or like other programs. And usually you take the key layout and you overlay that with the image that you generated, that you captured. Is that okay? So you take these, the pin decoding. Wait 1 second. These key measurement lines. So whenever you move a key pin up and down in a lock, it's setting it to a different value. And your key is basically just a password containing a bunch of numbers, and those numbers are just the heights of all the different key pins in the lock. So when you're trying to decode a lock or a key, all you're doing is you're taking the existing heights and you're transferring them back into their bittings. or their key biddings. And once you know the different heights, you'll be able to recreate it with your own machine. You can do this with key blanks by just taking a file and filing down the key, or you can actually do it with a legitimate like key making machine. I don't know of anybody here who owns one of those though, so good luck with that. And then if you actually have access to the physical key, instead of like creating a mold or like casting it or anything, you can just slide it along these little cards, and if the height that it stops at is the height that bidding is at. So if let's say quickset, for example, like if you have like a really high value on your, or a really like raised portion, it's going to give you like a 1 or a 2, and that just means that that area corresponds to a key pin value of 1 or 2. Awesome. I don't know if you guys have ever seen these telephony boxes around, kind of look like this. These are like remote access stuff that you'll show up. Let's say you're requesting access from somebody in the building, and you can basically like buzz the people who are there and ask for access. They're pretty much key to like. So mostly Door King. There's some other ones that are very key to like, but Door King is like very, very common, and it has the 16120 key. So if you just have this key, you can just open any Door King out there. And that's kind of crazy to me, at least. And something that's interesting with this is that you see these little white pieces of metal here, these bare pieces of metal. Yeah. So if you connect these two traces, some of these traces here, I think these two here. I could be wrong on that, but I believe it's those two there. It sends the post office request to, hey, I'm the post office. Please let me in so I can deliver your mail. And then it just opens the door for you. No matter how the Door King is set up, if you trigger those two, you'll be in. So, yeah, any questions about any of that so far?
So essentially you're saying any Door King, as long as you have the key, you can get into that door.
Yes, so any Door King, as long as you have the key and it has been key to like, and it wasn't changed by the sysad or the operations admin. Almost all of them are key to like. They even like, yeah, they're pretty ubiquitous key to like.
Okay.
And they're extremely common. Like before, I didn't recognize Door King like at all, and I started like being interested in physical security. And then I came back home from college, and on my neighborhood to get in was a burn. So it's kind of everywhere. Anybody else have any questions? I know I'm kind of speaking through this.
So
No?
what's the point of having?
So the reason that you would have them is that well, their purpose is to contact people or residents or people who work in an office to request access. So let's say that you work in a really big office building, and in front of the main entryway, right, there's like this box here, and it allows you to contact somebody who's supposed to be expecting you, and they'll buzz you in. That's kind of the purpose of these boxes. So they're more of an access control method. Yeah, did I answer your question? Okay, cool. Awesome. Now we get to the latch. So there's a lot of interesting attaches with the latch. We talked about padlock shims on the left. You can also these. I don't know if this is supposed to be in the latch, but there's all there. These are the middle ones are decoding shims. I guess I threw the shims in here because they're all shims. And then the right is just pieces of plastic. They're just varying degrees of thickness. And then if you push them between a latch, if it is improperly configured, you'll be able to just open the latch by just pushing the latches up. Yes. Say that again? Yeah, exactly. So those are more for like handle latches. So those are more handle latches. Sorry, I should have clarified that. And the ones in the middle are decoding shims. Those are for more like combination padlocks. You can put them in between the dials and pull the bar back against the dials and feel the gates. And once you feel the gates, you're able to decode it. That's why it's called a decoding shim. I'm sorry, I forgot to talk about that. Yeah. If anybody else has any questions? Awesome. Yeah, and now we have the traveler's hook. This is pretty cool. I have one here. It's pretty simple. It's just, I mean, you can get them at Lowe's or Home Depot. It's just a little piece of wire that's kind of bent at the end. And what this allows you to do is walk up to a door, put it into the side of the door and put it behind the latch, pull it back and twist it in. And if your latch is improperly configured, it'll pull the latch back, twist it in, and you'll be able to open the door. So what do I mean by improperly configured, right? So you guys are security people. This is probably something that you should definitely check. If your door is improperly configured, you're going to actually, have you guys ever noticed this little thing at the end of your door? Yeah. Do you guys know what that's for? I feel like some of you would definitely know what this is for. No? Say that again? Similar. So you notice how some doors, when they're closed, one side is like you're. So this is more of an internal mechanism for a lock. So instead of when you physically activate the lock, right? When you push it to like when you actually lock the door. This prevents the latch from moving unless it's actuated by the handle or it's actuated by the key. So usually you want your latch to move out of the way when you're closing the door. That's how like it doesn't slam on the door. So the way that this works is that once this little dead latch, as it's called, is pressed, the latch becomes dead. It can no longer move past a certain point and it becomes stuck in the door. So the purpose of this is to prevent stuff like shimming that we just saw earlier, or using the traveler's hook to just kind of move it out of the way. So you have to keep it depressed. So the way that you protect against this is you properly whenever you buy hardware for your handle or your lock or anything, it's going to come with its own strike plate. And that strike plate has to match your lock. If it doesn't match your lock, if it's too big, for example, it's going to fit the entire lock and the dead latch inside. And if it fits both the latch and the dead latch inside, then you're able to shim the lock. So a lot of people really like these giant like open holes because it makes it so easy to like close the door. You know it's going to be closed. Any door you put it against, you just take that giant like strike plate and you know it's going to work, right? But the thing with that is that, well, now you've opened up the vulnerability to these attacks we just saw. So yeah.
Colin,
Yes.
I guess how do you detect if a door is vulnerable? Do you just try it and see if it works?
You can try. You can sometimes see. So if you take your trunk tool and you walk up to a door, you can actually just, especially on this one because I know it's improperly configured, you can kind of just move the dead latch aside. And if you can see the dead latch and you know that it's not like you can. This kind of has a large gap here. You can just kind of peer inside and see.
Should we? Okay.
Yeah, if you guys want to come up at any point, you can just test out some of the things I'm talking about. I don't care if you get up, walk around, do whatever you want. So yeah, we've talked about latches, a lot of different ways you can attack it. Let's talk about the handle. So this is probably one of my favorite attacks. It's probably one of the most glamorous ones you've seen. The underdoor tool. Have you guys seen the underdoor tool before? It's pretty famous. It's one of my favorite attacks. It's right here. It's just a little piece of wire and some string. You slip this under the door, pull it up, move it over to the handle, and pull the handle. That's as simple as that. So this allows you to open the handle from the inside of the door. And it's pretty easy. Actually, I have a pretty good example of a video here. Just kind of demonstrating its use. And you guys will definitely be able to try this if you're interested. I think it looks kind of silly when it does it, but I also love it. Right. So that's an example. That's Stephen Olam. If you guys are interested in physical security, I'd definitely check him out. Awesome. So we went under the door with the underdoor tool. We can also go over the door with the overdoor tool. You guys are familiar with what this is, right?
Oh, no.
No?
No.
No?
Oh, that's with that offer specifically, so I'm not.
familiar with going over the door.
Okay, so yeah, this is just basic 35mm film. It's dead now. But basic 35mm film. So when you take this out, I actually might need a little bit more.
If you want, I can use a camera on here. And it's sugar off the screen.
Well, I naively grabbed a new cartridge instead of the one that I had straightened. So, okay, think of it, we're gonna watch the video because I don't believe we'll be able to use it when it does that. But if you have a straightened piece of 35mm film, you're able to feed it. Sorry, you're able to feed it over the door, put it over the handle, loop it across, and then pull the handle upwards. So that's, again, from our friends GBM and lockpicking lawyer. I also think this is just funny how slow it goes now. Sorry about that. But yeah, I think yeah, it's pretty much the picture. So once you push it down, you push the outer end out a little bit more, so it creates a loop, and then you slowly move that loop over to the handle, and then you pull up on both of the strands at the same time, and then you are able to open the handle. So again, this is another another way of accessing the handle from the other side of the door. Awesome. And there's your friend again. So how do you guys think you protect against these? There's a lot of different ways you can protect against them. Knob handle is a pretty good one. Deadbolt's great. Yeah. Yes, whichever.
Wow.
You mean like what kind of lap? Like a
It's like, it's set against.
oh yeah. Yeah, yeah. You can definitely do that. There's also attacks against that. I don't think I have that in this presentation, but yes, that's a good answer. You have one? That, yeah, maybe weather stripping. While that is a deterrent, I would not say that that is a preventative. But that is a good answer, yeah. There is, I don't know if you've ever seen, sometimes, I wish I included a photo of this. Yes. Say that again. Deadbolts are great too. Yes, deadbolts are a very good answer for this. Very good answer for this. There you can have little lips that come out after a door is closed from the bottom. They'll pop up and just close off the door. And when the door is actuated again, they'll open it. And then for over the door attacks, you can kind of just have like a shielded barrier over it. Just kind of go up or for that. That should conquer most of those. Just anything that'll keep the film away from the door. But for the underdoor tool in specifics, specifically, there's these little clips. I think I have one here. Little clips that you can put on your door that are usually for stopping carts, like hotel carts or like other objects from just kind of ramming into your handle and damaging it over time. But this does a really great job of just blocking the initial handle from like being accessed. Just kind of put this over, like put this over. Sorry. Put this around your handle, and the underdoor tool will just kind of like slip off and not be able to actually get your handle. This one's a little small for this handle here. I feel like you'll still be able to actually actuate the handle with this one, but they do exist. Awesome. So we talked about single latch. You can also actuate double door tools or crash bars by using the double door tool. So you just kind of pop it in between the glass or the.
How does it work? I think you guys can figure it out.
Sorry about that. You pop it in between the door frame. You move it over to the crash bar. In this case, there's a handy handle that acts as a crash bar, and you just pull against it like that. It'll. Oh, sorry about that. Spoilers. And it'll actuate the crash bar and open the actual door. So it's just another way of attacking another handle. Awesome. A great addition to underdoor tools is actually a borescope. Yeah, so these are borescopes. I Googled like borescope looking under door, and WikiHow was the only article that had something about it that I could find pretty easily. So yeah. But yeah, borescopes you can use for a lot of things, investigating places where you can't actually see. But if you want to, I don't know if you noticed, it's kind of a little obvious when you're using an underdoor tool from the other side of the door. People kind of tend to notice the giant metal thing that's kind of clashing against the door. So you want to make sure that there's nobody there. So this is just another surveillance thing to make sure you don't get spotted. Awesome. So access control and egress, especially with request to exit sensors. Sorry. So are you familiar with request to exit sensors? I know you're here on UF, so you've at least used them before. But if you haven't like noticed them around, if you ever kind of walk near a door and you'll just hear it kind of boom or click or like make a noise, it's as it detects you, that's an access to that's a request to exit sensor. So they'll kind of look like that on the bottom corner here, on the top right, and they'll just they'll observe pressure, temperature gradients in the surrounding ambience to determine if there's a human there. So if the rest of the room is like, I don't know, like 70 degrees, and then there's 80 degrees there, that must be a human or like something. So it detects that temperature difference, and then it says somebody's there. I'm going to open the door for them because I'm a nice like robot, and I want to make sure that they get out holding all of their boxes, and so that they don't have to like fiddle with their access key on the way out. So how do we take advantage of this? There's another way. You can also do motion sensing, although that's not as common for request to exit sensors, but it is still there. Maybe not what you expect. I know some of you have probably already known, but it's just a can of air duster, right? More specifically, when you turn it upside down. You guys are familiar what happens when you turn one of these upside down?
No.
No? Well, that's what happens. So yeah. This contains compressed air. It doesn't actually contain air. It contains, I think, R3, no, 1,1-difluoroethane. So maybe don't breathe this stuff in because I think it might get you a little too what?
You say after spraying it everywhere.
Well, no, and it's fine, but maybe don't like spray too much of it. But yeah, so what this does is you see all the visual effects and like crazy wow, but what it does is it creates a pressure difference because you have compressed air in here. When it comes out really cold. And so the temperature sensor is like, oh my gosh, temperature difference. There's a human. I must let them through. But it's not really the best. There's actually a lot of better things like R134A, which is a refrigerant. You can just get at the store. It's not as bad as the stuff that's sometimes in cars. And then there's also tech spray, which is just used, it's the same thing. It's used on diagnosing motherboards. So if you have like a fault or something on the board, you'll be able to detect where all the heat is at because you'll spray this. It'll create like a cold layer of ice, and then it'll heat up the board in the areas where there's like excess electricity. So yeah, this stuff is interesting stuff, but I wasn't really super satisfied with this because I don't really want to carry around. Yes. So yes, so the sensor, we are on the outside, right? And the sensor's on the inside. We're taking, here, I didn't, wait, no, it's coming up, I guess. Okay, I guess it's coming up. I'll have a video showing a request to exit sensor in action. But yeah, so basically you're on the outside, you're shooting this through the crack in the door. And then it's triggering the request to exit sensor that's on the inside saying that there's somebody who wants to leave, open the door. And then you're like, yes, I will come in. So that's how that works. Sorry, I should have made that clear.
Would it work with anything that, if you left hairspray in the fridge, and with the same trick apply?
Yeah, so temperature gradients. So if you have something like, I don't know about hairspray in the fridge. I mean, it probably would work. But I don't know if that would create enough of a temperature difference in order for it to be registered by the sensor. It could be, I'm not sure. I've never tried it. You're more than welcome to try it. Maybe not in UF infrastructure though. Yeah, there was a video in here, but Adam told me not to show it. So okay, so I wasn't super satisfied with this. There are some stuff that's out there that's portable. maybe not as cost effective, but you can buy R134A canisters in these little things. Take these at the end there. That's a little bike pump. So if you ever are on the side of the road and you need to refill your bike with CO2, if you're on a race, you'll take a CO2 cartridge, like one of, actually not one of those, like a CO2 cartridge, and you'll put it in the bike pump, and you'll push the button and it'll inflate your tires, and then you're back running the race again. So this is basically just a portable version of this, except it's better because it contains R134A instead of 1,1-difluoroethane, which is just has a larger temperature difference. But those are really expensive, and I'm a college student. So if you guys are interested in recreating what I do, if you go to Walmart and you just get these CO2 canisters that are for refilling BB guns, they're kind of small like this. They don't fit in any like standard gas like bike pump because nobody wants to fill up a quarter of their tire with one of the little canisters, and they're not threaded. So usually what you do is you thread the insert into your pump, thank you, and you inflate your tires, or you flip it upside down with the R134A, and you access the access, or you activate the access control. With these, you put it in an adapter, and you put it into a specific bike pump, and it punctures the top of the gas canister, releases the CO2 in this pressurized container right here. And then once you're once you want to actually activate, like let out all the gas, you just flip it upside down and you push the lever. Yeah. If you want to do something like this on a more repeatable thing, you can take these little things, modify your existing threaded cartridges and make them refillable by taking R134A and also dumping it back out. So yeah, and if you were interested in making one, that was how to do it. All right, so this finally, I really should have put this earlier. This is an example of rec sensors. So I apologize, it's kind of related. Awesome. Everybody catch that? I'm gonna do the ending shot one more time. So that right there is a request to exit sensor, and that is just a canister of air.
So all you need is the sensor for it to unlock the door when you just get in.
Yeah, exactly. As long as you have the sensor, you can just unlock the door. Yeah. As long as it's also configured to unlock the door. I mean, like that's kind of, yeah,
That's fair.
but they're kind of limited. So you need a temperature gradient, right? But some of them actually require a temperature increase. And some of them also require motion. So some of them are really hard to fool. Like request to exit sensors, you need like motion and you need to be warm. Like that's a lot of requirements for being a human. I don't know. Yeah. There is a way to do it in one. So there is a solution.
It's like,
I'm not sure. I don't know. I think it depends on what the sensor uses. I think it uses, I'm not sure. It depends. But this is an example for using attack to defeat both heat and motion. So they take that a little bit of we live in Florida, so maybe not everybody see this, but those are hand warmers. You just kind of shake them and they get really warm. And then they just took it on a very scientific tool. It's a long stick. I think that's actually an under door tool, but it is a long stick and they just kind of waved it in front of it. And then I opened the door. Awesome. There's also ways you can attack hinges. So this is a hinge pin remover. It's basically just a long pin with a built-in hammer. You pull it back, you let it fire, and then it knocks a hinge pin out. You just put it under the hinge pin, pull it back, and the hinge pin comes out. It's as simple as that. There are some ways to defend against this. I know I talked a lot about ways to defend it, and then I've neglected some of them. But if you have questions about that, I will be more than happy to answer about that. The ones on the right, if you look at how hinges normally are, you'll have like 3 screws on the plate that connects to the wall, and 3 or
do you want me to
4
put
screws
that on the camera? So
Yeah, sure. So 4 screws that connect to the door, and then 4 screws that connect to the wall. So the way that this works is that you take one screw out of one side, one screw out of the opposing side. I'll move this. Over side.
Yeah. Is really? Maybe closer.
So let's talk in general like generic so that people can see. There's 4 screws on each side, right? We're going to take the top one out of each side, right? And then we're going to replace it with the thing that we saw earlier, which is basically a screw with a little piece of metal at the end. So that when the door closes, you have a screw in here, and it just puts the little piece of metal into the place where the screw used to be in the other hole. Does that make sense? I can say that one time. So you have the screw with a piece of metal. Once you close the door, the screw puts the piece of metal into the hole where the previous screw was. And that's still somewhat confusing. I'm sorry about that.
Wait, are you saying you already need access to the door in order to set?
This is a security thing. So this is how you can protect against hinge pin, like knocking out hinge pins. Because you can just knock out all the hinge pins. It's pretty easy to get in a lot of places.
Okay.
Depends on like which side the hinge pins are on. That's what. So yeah.
Just share screen again.
Share screen.
Oh, yeah, share screen. Go ahead.
Awesome. All right. So there's also elevators. Yes. Okay. So yes. So once you knock out a hinge pin, right? Instead of having the door just kind of fall away because there's nothing like holding it up, that little screw will be it'll be putting metal into the other hole. So that once the hinge pin is removed and there's nothing like kind of keeping the two halves together anymore, you can't just walk the door away from it because it'll be connected to the other side of the hinge. Does that make sense? So the way that a normal like hinge pin attack would work is that you knock out the hinge pins, right? And then you move the door out towards you, right? So that you or out that way, I guess. So that you'd so the I should have a diagram of like yeah. So the hinge pin attack is there's a pin inside of a hinge, and it takes the two faces that mesh together, right? And it is what links the two faces together. So once you it's kind of like interwoven, like it's like a mesh. So once it goes through, it's like a bunch of interlacing circles. Once you remove the pin, those circles can like move away from each other. Yeah, I'm sorry. I should have a photo of a hinge up here so you guys can see it a little bit better. I apologize. That's an oversight on my part. Awesome. Thank you for pointing that out. I did not see that. I forgot that I put this there. So you take out the hinge pin. Or you put it back in. Okay, this will probably be better. So that's a long hinge pin that they took out. And then once you see they're each like little cylinders, they take out the hinge pin, you can just access the lockbox because you can just walk the door away from the hinge. No matter what kind of like latch you have or what lock you have, if you can access the hinge pins, you can just open the lock or open the restricted area, I guess. Awesome. So there's also elevators. Elevators are like an OP stairway. Yeah, I mean, because there's a lot of things you could do. I would say that don't like start messing with stuff, like don't buy elevator keys online and then start messing with them, because a lot of the ways that elevators work is kind of like you kind of have to know like the different quirks of elevators in order to start working with them. It takes a lot because they've developed a lot over their time. There's a specific switch on there that has you have a key and you have shutdown and then you have on as two different states. So do you think turning it into shutdown or on would be shutting down the actual elevator? It's kind of a toss up, but turning it from shutdown to on turns shutdown on. So on is when it's shut down. So there's a lot of semantics like that in elevators. So I would suggest maybe not attacking them or like fiddling with them unless you like kind of know a little bit more. If you would like to know more, there's a 2-hour elevator talk here that that I would definitely recommend. But yeah, so basics of elevators. So you guys have probably already heard about fire activation. So when a firefighter needs to get there, if the elevator first detects a fire, it'll send all of the elevators down to the first level. If the firefighter gets there and that hasn't happened yet, they can initiate the send all of the elevators onto the first level. The case where this might not happen is if the elevators aren't tied to the rest of the system and that they only have their own smoke detector in front of them. The shaft that they occupy.
How to get into the elevator?
So the one that initiates phase one, which is when all the elevators come down to the ground floor, is on the ground floor and you can just turn that. Yeah. So you don't have to be in the elevator to do that. But the one that we're kind of familiar with is phase two, where you just kind of turn the key and then it acts as your own personal chauffeur. You can go anywhere in the elevator. With the same key, it's all key to like. But again, I would say maybe don't mess with elevators. But that is definitely an attack option I would suggest learning about in the future. Yeah. And then an interesting attack surface is people. So maybe that's a little harsh way of saying social engineering, but I guess it is kind of a harsh way to say social engineering. So yeah, there's badge cloning and impersonation. This was a photo posted, I think, about a week ago of just a conference in Orlando. And now I have their badges. I blurred them out because they seem like really nice people, but I will don't. But I just want to say that it's really common to see badges online. If you want to like research about a company or anything about them, open source intelligence is a really big part of physical pen testing and like physical entry and all that stuff. So you can take a photo like this and create your own badge, and then suddenly you're somebody else, or you can impersonate somebody at the company to do something. A lot of the times, physical pen tests will have certain requirements that you are trying to achieve. So like accessing a certain room or like gaining access to like sensitive information of a certain type. So this can aid in that quest because you'll suddenly have more permissions than you thought you did. And yeah, there's an interesting story that I heard at besides Orlando, where this person was standing outside of a facility that they were interested in pen testing, and they used to work as a network provider, so they are intimately familiar with the network operations and everything. So they just walked around the building, found the main cable for the internet for the building, and just unplugged it for about 10 minutes. And then they plugged it back in. They went inside and they were like, "Hey, I'm with your local ISP. Have you guys noticed anything weird going on recently? There was something weird going down the block. I just wanted to see if you guys have anything odd going on." They're like, yeah, of course. Actually, we're so glad you're here. And he's like, "Yeah, actually, while I'm here, do you mind if I check out your infrastructure? Like, just make sure that everything's going according to plan. Make sure that the endpoints are working, or not endpoints, but the inputs working from our thing. Just want to make sure just that it's applied and it won't affect you guys like it affected them." But yes, of course. And then suddenly you have access to the data room or the server room. Or like we talked about earlier, elevators are really powerful. Otis is a really big elevator company. They are like the repair technicians of the elevator world. So if you walk into an elevator and you turn it off and you just kind of exist in the elevator for a little bit, or you do something else, and then you show up as Otis and you're like, "Hey, did you guys have elevator problems? Like we got a notification on our system." And they're like, yeah. So this is just pretexting. So it's getting people to anticipate you and accept you and being part of they instead of you trying to worm your way in, they're like, yes, we do need you. Please fix the issue. And then you'll have a lot more trust that way. It's like reverse social engineering. There's also baiting. I'm sure you guys are pretty familiar with the USB left over the parking lot trick. And you just kind of wait for people to plug in the USB that you scattered everywhere. But there's a lot more malicious ones out now. If you just see cables lying around, they can have little mini computers in them as well. Or QR codes are all like suspects as well. So there's just a bunch of different ways you can get people to access information, either physically by putting up specific devices or like images in places where people will be, or like just honestly like getting them more toward, like pointing them in a direction where they'll be exposed to your malicious activity. Awesome. And then on there were some interesting photos. I Googled like like watching somebody put their password in or something, and it popped the first, like one of the first things was Chad, the password snoop. So I decided to share them with you. So yeah, there's Chad, the password snoop. So you can just always be aware of people watching you for your passwords. And then a really simple thing to do is just kind of be observant. You'll be surprised how many people just openly enter their passwords right out in the open with no security and like just typing away. And that can be really easy to just, cover and obfuscate. And then as well, like sensitive information, documents, and other things. You always want to make sure proper disposal of all that stuff. Awesome. And then a lot of the times with social engineering, a simple solution is really the best one. If they're opening the door for you, like no matter how reluctant they are still opening the door for you, right? So I mean, you might as well take advantage of it, right? So yeah. Awesome. We talked a little bit about access control systems earlier as well. There are different things that you can do. There's the ESP key on the left and the proxmark on the right. The proxmark is more for actually like copying credentials, while the ESP key is more for like capturing and replaying signals from the access control system. What I mean by access control system, I'm sorry about this. What I mean by the access control system is you guys have like, if you live on the dorms, you'll have like a fob that you scan against like a plate, and it'll like beep green at you and you'll able to enter your room, right? So something like this, where you have like your RFID or your badge, you're able to capture that data. And if it's not encrypted, if it's able to be like replayed, then you can now become that person. You can also an interesting attack is actually spoofing a reader. So if you use, I believe, a proxmark, and you get kind of closer to someone and they have their badge near them, you're able to act like your own reader. So instead of them having to place their badge against something, you just kind of walk next to them, do nothing suspicious, walk away, and then now you're that person's identity. So there's quite a few ways you can guard against this. Probably one of the simplest ones is to just take tin foil, like aluminum foil, and wrap it around your card. It sounds kind of like a conspiracy, but just a little piece of metal that'll block the electromagnetic frequency because it's going to interact with that metal instead of your card. It'll zero out that.
Wait, Colin.
Yes.
Just to be clear, when you loop in, you have to take the tin foil off.
Yes, you do.
Okay.
So yes, they make little key like access, like if you have like a key card access instead of like a fob, they make little containers for it. You can just put it on like a little lanyard, and so it'll sandwich your thing in. It's actually just one side of aluminum foil, but since it has so much contact and it's so close, it's enough to block the communication outright. But once you just lift it away and you put it close, that's you're able to actually badge in again.
You actually do it with your phone, like you can play music and you wrap your phone in foil, or actually you'll see where you find like it's secure. And like all.
Yeah, exactly. It's pretty interesting. You just remove the electromagnetic communication. And also Hall effect sensors. So there are magnetic switches which you can detect when doors are opened or bypassed by an attacker. And if you want to bypass this, you can just place a powerful magnet near the Hall effect sensor, and it'll still believe that the door is actually closed or open, or whichever state you want it to believe. So an interesting, like let's say that this door like had access control on it, and we wanted it to not have to sound an alarm. We would take a little magnet on like a rod and kind of figure out where the Hall effect sensor was in relation to the door. We'd take one of these little mag switches, we'd place it up against the wall, and we'd turn the magnet on, and we have a powerful magnet now believing that that no matter what, the door is going to be closed. And now you can still attack the door, open the door, and the alarm won't go off. Awesome. So that's most of the stuff that we talked about that I wanted to talk about. We still have a bunch of tools up here if you guys are interested in testing out any of this stuff. If you have questions, I know I didn't cover a lot of things because there's just so much to talk about in such a little period of time. But I implore you to test all the stuff up here. So thank you. Thank you. Yes, you. Yes.
So like the fog?
Yeah.
But I use like a fog. Yeah, it's the
NFC or I'm not
I see mine just hard in, like sometimes you phone, it's like a center.
probably yeah. So I know I know New York has
It just reminds me of center punch.
I would
Yeah, she's in.
the problem is
Yeah, I make like you did all. Like you went out every possible combination. It's straight phone against the phrase. Probably because there's so.
I'm not too familiar with NFC or RFID stuff. So I imagine that it's probably a lot. They try to force, but in theory, I think we could do like an hour. It might take another people. I don't
Not be on.
Yeah,
Goal is
I'm
to
sure
break the lock
that's-
out of it. Not the door itself. No, like actually.
Oh, if you guys are interested in maybe don't.
The goal is to break the wood around it.
Maybe don't do it on this.
If you hit it here, you're gonna break the lock.
Yeah,
Yes.
You wanna try, you gotta tackle watch.
it's all good.
Get it wrong, like, so no lockpicks.
Lockpicks. Do we have lockpicks?
Try it. That won't be that hard to break. No, it's a little more in the bottom. Watch this, Michael. I just said the same thing. Remember, aim to the right of the lock and not next to it.
It's not that.
It's like a bunch of 2x4.
Wait.
Let's go.
Be able to save anything for the fire, everything, we'll be able to get out, arson.
Just keep the door in. Come on.
Or like any of the laptop
You guys
passes.
don't have your handy games.
I'm sure white people will have to rush.
Your pro only recommended.
You're pro, working, but maybe not right now when we're just. So this is the first year we're having to like.
Are we trying to take things off?
Can you explain the
Yes.
the security, since we're all over here now,
For which, for what, we're, for.
to prevent the
Yeah, yeah, of course.
Since we're all here,
I apologize. Okay. So you'll see here.
shimmy around everyone.
Gather around,
Gather
Gather around.
Okay. So imagine that instead of a screw here, you have a screw and then it also have a giant spike coming out of it, right? And then this is a hole over here, right? This giant spike is gonna go and it's gonna enter this hole, and then once you close the door, right? You'll have a giant, like a bar going in between the door and the wall. Yeah, kind of like an exit where they have like that, it's kind of like a dead latch. So this becomes its own dead latch, and you'll have your latch on this side and you'll have a piece of metal on this side. So you're gonna not be able to actually, because the way that the hinge pin like attack works, is you're gonna be able to walk the door away from the latch and not have to deal with the latch. You can have a problem. And if you're not able to like actually move it away because there's a bar here now, then you can the latch or the latch or the.
Yeah, you had the screws next to the photo for the bang remover. And
Yeah.
so we all thought it was part of the attack.
No, I'm so sorry about that.
Kind
I
of
should have been a little more
that's all.
informative. I'm so sorry. Does anybody else have any other questions? I would definitely be down to answer one. Yeah. It took. I'm not exactly super handy.
Oh.
I'm yeah, it took about.
Alright, road trip. We
Uh,
go by lockpicks, we break it in multiple places.
definitely, want to try attack with the, you attack from this side. So this is the side you attack from.
That's the test.
This is the inside. This is where you guys want to get to. This is the side where we're attacking from.
It depends on the building. Outer doors, hinges are always on the inside. Florida building codes.
Yep.
Actually, no, wait, no, it's the other way. Hinges are outside.
Yeah, you want to keep that.
Oh.
Yeah, there you go, there you go.
Huh?
I think the security guards got cheese.
You can't have
I think the security guards got.
No, it's okay. You
Triangle factor.
Oh, yeah.
Is anybody interested in like blasting around compressed air or like
I bet the
Yeah.
person built the wall. I mean,
lockpick set? One
He was
second.
my professor. The reason why doors open out in Florida is because when they open in, it just, the air sucks in and it's like, I have nowhere else to go. Through the roof, and it blows the roof off.
It was also a good thing to make sure that like you're inside the doors open.
Very cool, very fun. You gotta rotate to. Nope, there's no way. Well, you're away from the door.
Outside because they were panicking. Everyone.
There you
was
go.
like,
They're trying to push on the door. when
Yeah,
pulled.
but they couldn't open it.
That's
Yeah.
insane. I did not know that was.
Yeah.
Nope, almost.
The air thing also makes sense.
I don't want to get that.
It's specifically a Florida building.
Yeah, fine.
Specifically, Miami, they have insane building requirements.
For good reason.
Yes. Oh, no, I met the dude who built the wall of wind at FIU. He was my professor in high school.
Oh, wow.
The building codes we have, yeah, it's his fault. I can't build my full house with only interior opening doors. Got it. Oh,
Too much.
oh.
You want to move the line over more to the right of your tool, so that way we're gonna like pull to the right instead of to the left. Or
I believe in you.
yeah,
you got Oh,
and then try and pull the door towards you because you're gonna want to pull it open as you're pulling down the handle.
Yeah, you're on, just pull the little.
Okay, so I'm
Yeah,
gonna.
like,
I have lockpicks on me. Yes. Oh wait, do I not have lockpicks?
I think also like
Yeah, take.
sliding.
I don't have
like,
lockpicks.
heavy
One second. I might have. lockpicks.
Once you're over it.
So curious why there's a ruler on the other half of the door.
It was. Oh, did this?
Yeah, the ruler.
It's the door doesn't open.
Oh, it's fine.
Oh, it's okay.
It's a stop. There's a lot of. Yeah.
It kept falling open, I'm guessing.
Well,
So
yeah,
it's like,
if you
oh,
look
this
at
is
the
the door.
doors, they'll have like a rim around the.
Oh, this one does not. Oh, okay.
So it's
You
just a
guy
passing
a door with ribbons.
I didn't really talk about this. This is using a TLA to heat pieces of metal. This is for when you're casting gears.
For what?
This is when you, this is when you want to cast keys. You take little pieces of low melting point metal, you put a little TLA under here, you melt the metal in here and you just pour it in here.
Do
you have, like,
Your lock will have no magic.
Yeah, I should. If I don't,
Drug up the power drill. Feeling in me telling the local crack addict that behind the door.
No one else wants to have to go.
My favorite joke I've seen about that is someone in New York told a bunch of crack addicts like, hey, it's inside the part of the structure.
yeah, so the airbag is,
The
door is
Trying to find
you put this under the door and you push this a bunch until it inflates, and then once it deflates, you'll have more room. This one should have way more.
Oh, no.
Never able
Do you have any
to-
cores to pick? Do you have any cores? I think
Yes.
Okay, so
When you're on.
Guys, we're almost there, I swear.
they're on the way.
Oh, they're on
They're on the way. It might be a bit,
So that.
but they are on the way.
Yes,
I do have a friend who has been.
My favorite one is the New York rags.
Something's vibrating.
Have you seen an image of one of them? They're so
Thank you.
big.
Thank
Is
you.
that
You're
to
horrified.
like leverage the door?
This?
Yeah.
Yes.
No, no.
So this is more for the underdoor tool. So if there's not enough room for you to maneuver, if you need more space, you just
Like one of the things-
I think it's leverages the door.
yeah, it moves the door up, and suddenly you're able to access the door.
Surrounded by rats.
Say it again?
And you
Oh, I don't know. I just got this on. So
The scenes of Ratatouille where the inspectors is there and all the rats are just looking.
somebody was asking about the putty. I don't have the putty. I'm so sorry, but I have photos of it online. For key casting.
Oh, yeah.
Oh.
I do have it. I did make my own.
You can't tell them.
Yeah.
So it looks I don't actually,
So there actually
Don't do it,
things
don't
where,
do it.
you said that like you can take a picture and like other programs where you can get the
I
shape of
said
the
that
key, right?
I don't know of any programs that you can use.
That underdog tool is hard.
Yeah, that's what the
Once you pull it down, you just grab the handle.
So you take some modeling clay and some like ingots. I have like just a solid block of it.
Yeah, yeah.
And you take it, and you push it like in this area. Yeah, this is the first one I
Yeah,
came
it's, yeah.
I don't have this one. I made my own. but-
That's like quietly
Or
laughing,
if you
and then they
pull
open
the
it.
mold of the key and you
Bill,
have a
I
bunch
hope
of
one
keys
day
available,
that's
you can
what
just
I yeah,
grind your own.
I put on my taco.
Say that again?
Like
Just
if you
sitting
have
here
a bunch
like
of
a
like
chair like
blanks,
that's in America.
and
The
you,
moment
and
they
you have
open
the
it.
casting,
Stop.
you can just cast
You wanted to get
it
in.
with whichever blank.
Oh,
is
100%. Yeah, so the casting, just for the mold, I would say that it's great to have if even if not for the actual casted key, if more that you'll now have copy you can handle. So like
If all else fails, you can just measure your cast
Exactly.
to get the pin numbers for each of the pins.
exactly. So then you can just recreate the key.
Yeah.
So once you have physical access to the key, it's kind of game over. It's now no longer a password, you have it.
Yeah,
So-
yeah.
I definitely want to try it next.
I talked to him.
Awesome. Yeah, and then we have this, which I think is fun. Maybe I'm biased because I made it.
Request to access.
Yeah, with a request to access or request to exit center. So that's it. I might have said access, I'm sorry, but the request to exit sensor.
I'm tired, so.
So
Yeah.
you'll hear it pop.
Something wood's clicking.
Does that.
Oh, everything.
So, it's carbon dioxide. So yeah, that's that. Once it reaches the pressure, it'll just equalize. So
You got any material on just using door bars?
door bars?
Yeah.
Yeah, I mean, double door tool, but I mean, I wouldn't suggest that for that. I mean, you can use a modified under door tool for door bars. I can pull that up on that.
Probably gonna be something lots different.
Oh, did you stop the recording? Mo? Stop recording.
Where?
They heard
Second from the top.